Good evening, everybody. Welcome back. Glad to have you. Today I want to teach you how to find missing legs in right triangles. We've always found missing hypotenuses, if that's even how you make hypotenuse plural. Today I want to talk about how to find missing legs in right triangles. So open your math notebook and make this the title. When you've done that, close it, clear your area of distractions, turn on that brain, and unpause when you're ready to go. So as I said, we've always been finding a missing hypotenuse in all of our right triangles so far with the Pythagorean theorem, saying that a squared, which is a leg, plus b squared, which is a leg, equals c squared, which is a hypotenuse, or in this case, z squared, and 19 squared equals whatever c is squared. 18 squared I don't know, 324. 15 squared I do know is 225. And those should equal c squared together. Add those up. 324 plus 225 is 549. So remember, that doesn't mean that this side is 549. It means that this side squared is 549. So I would apply a square root to each side and find that z or c equals that. 23 and about. I'm going to do the approximately, what was it? 23 4300ths. We've always been missing the hypotenuse was the key. Today, we're going to miss a leg. Little different situation. Here I've got the hypotenuse, missing a leg. Haven't run into that situation before. Let's talk about what to do about it. Not that different. I'm still going to apply my Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Notice here the right angle is here. The hypotenuse, we're used to the hypotenuse kind of being at the top. It's just whatever's across from the right angle. 7 squared plus whatever that is squared will equal 18 squared. So I'm just missing something different. Usually I'm missing this. Today I'm missing this. My variable, my unknown, is there. Let's deal with some exponents to make this a little more clear. 7 squared is 49. X squared, we don't know, equals 18 squared, we can figure out. 324, I just did that. Should have remembered that. So now, whatever x squared is, when you add 49 to it, should make 324. So we need to find x. This is a variable equation, and there's two things happening to x, an exponent and addition. So we do those in reverse GEMS order, don't forget, or SMEG order. So I'm going to deal with the subtract and add first before I deal with the exponent, if I do this with algebra. So let's do that. So the inverse operation of adding 49 is subtracting 49 from both sides. Those cancel away. And whatever x squared is, it's going to be 324 minus 49. So it equals 275. Now, that's done. Don't have this. All that's left now is to deal with the exponent. X is being raised to the second power. The inverse of raising to the second power is square root. Take the square root of both sides, and we find that x equals that, about 16 and a half, a little more than 16 and a half. X is about 16.58 units of whatever kind that is. That's how you do it. So it's a little more work than here because you've got to do some algebra. You could probably common sense your way to the answer too. When you get here, you could probably do some common sense to figure out x. That's the formal way to do it. That's how I'll show you. But it might work. Open your notebook. Let's do one together. And what I want you to point out first is today what's new is you're missing, this sounds bad, you're missing a leg. Not you're missing a leg. You need to find the length of a missing leg. How about that? Rather than the hypotenuse. Here the hypotenuse is given, hasn't been before. We're missing a leg. That just doesn't sound right when I say it that way. Here's the right angle. The hypotenuse is across from the right angle. Make sure you know that. So the way we do that is let's just give this a name. We're going to, we like to do a squared plus b squared equals c squared, so we'll call that b since there's nothing there. So I know I can still use the Pythagorean theorem because this is the right triangle. So a squared plus b squared equals c squared. I'm just used to missing c, now I'm missing b. Or a, doesn't matter which. 7 squared plus whatever b squared is going to equal 14 squared. So a little math here, that means that 49 plus b squared is going to equal 196. Should have known that one. Now there's some work to do. You may be able to common sense it from here. You may just be able to kind of figure out with some common sense what b squared is, then take the square root of it without doing algebra. I'm going to do it with the algebra steps. It's reliable. And stuff like that's going to keep coming up in the future. But you could probably common sense it from here, and that's fine if you do. So what I need to think about here, there's two things happening to b, squared and addition. So I do those in reverse GEMS order when I do algebra. Rather than just solving it, I'm undoing, going backwards to find b. So I'm going to do subtract and add first, and I'm going to do exponents second. So the inverse of adding 49 is subtracting 49 from both sides. So now I have that, if I do my kind of formal algebra, b squared equals 196 minus 49, 147. So now I've done this, subtract and add. Now the inverse operation of squaring exponent is square root of both sides. So b is going to be the square root of that, which is that, a little more than 12. So b is about 12 and 1200ths, which seems right. You can kind of tell, remember my hypotenuse has to be the longest side. That's shorter, that's a good sign. Probably got it, or got pretty close. And that is how you find a missing leg. Not terribly different than what we've been doing before, but it is a different kind of problem. So I wanted to make sure I showed you how to think that through. I hope this made tons of sense to you. I hope your concentration was strong the whole way through. If it was, and you feel good about what we've just done, you're all set. If not, give it another go, and I know you will be after that. See you tomorrow.